Hey friends, this is Scott. I want you to know how much I appreciate you as listeners, and I hope you appreciate my sponsors because they make this show possible. Raygun provides full-stack error, crash, and performance monitoring for tech teams. Whether you're a software engineer looking to diagnose and resolve issues with greater speed and accuracy, or a product manager drowning in bug reports, or maybe you're just concerned you're losing customers to poor quality online experiences, Raygun can provide you with the answers. Get full-stack error and performance monitoring in one place. The next time you're struggling to replicate errors and performance issues in your codebase, think Raygun. Head over to raygun.com, that's raygun.com, and get up and running within minutes and dramatically improve your online experiences of your users. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. And today I'm talking with Dr. Neil Brown. He's a research fellow at King's College London. How are you, sir?
I'm fine, thank you. How are you?
I'm lovely, and I'm always excited to talk about teaching programming. And you recently published a paper in a computational biology paper on 10 quick tips for teaching programming, which almost sounds like a fun blog post and not a formal paper as a title.
Yeah, it's nice actually to write a sort of summary paper. So none of this is particularly our own research, but just to try and write a summary for a general audience of how to teach programming.
Mm-hmm. And this is like kind of a summary of research around the space of educational psychology, like how people's brains absorb, how teachers should teach, how children learn subject-specific activities.
Yeah, that's right. So one important sort of result from education is that each discipline is sort of learnt in a domain-specific way. So there's a bunch of general education or sort of teaching tips, but a lot of the ones that are very useful are domain-specific. So how you teach mathematics is different than how you teach programming, is different than how you teach science. And computing doesn't really have as long a history as some of the other subjects. So we wanted to try and get together some of the tips that people have researched and have shown work to try and sort of educate some of the computing teachers out there.
Mm-hmm. Is there one way or one more correct way to teach something? Because it seems like we've learned about different learning styles, acoustic learners and visual learners and kinesthetic learners. How can we say this is the right way to teach programming?
So interestingly, the learning styles thing has generally not been supported by research. So that one hasn't actually been found to be reliable. But more generally, there isn't usually a correct, single correct way to teach. It all sort of comes down to percentages to some extent. This seems to be reasonably effective. This may be slightly less effective. There aren't that many techniques that are sort of horrifically ineffective. And they generally aren't, in use in practical settings. So we're not out to say this is the one way to teach, but we want to say this has been found to be effective. Maybe you should consider it in your context if that makes sense.
I see. So this isn't a list of commandments.
No, it's really not.
Yeah, a list of directives and it's tips mostly. Like consider this. There's evidence that supports it.
Yeah, and teachers, we talk to teachers and they don't like anyone coming in and saying, this is how you must do it. They want to sort of have ideas that they can weave into their own teaching. Maybe they've got students where pair programming is not going to sort of pan out very well. And so they want to drop that tip. Maybe they've got a setting where they think it would work really well. So it's up to them to actually put it into practice.
Mm-hmm. The first tip, and I think kind of the one that hits the hardest, is that you say, remember there's no geek gene. Because in this world right now in 2018, we're trying to foster an inclusive environment where it's not just kind of old white dudes doing computing. And just as I mentioned before about learning styles, it intuitively feels like that is a thing. And you said that the research doesn't support it. It intuitively does feel like some people are geeks. And you're saying the research doesn't show that.
Yeah, so there's long been this idea in computer education of a bimodal distribution, that you've got the people who get low marks and just don't get it, and the people who got high marks and do get it. And, I've done some programming teaching myself in the past, and, you see some people who are struggling, and it's very tempting to just basically give up on them and say, they're just not going to get it. Well, the person next to them, for some reason, just seems to be flying, and you're like, yeah, they get it. And what the research seems to suggest is there isn't actually as big a difference as people think. And there's a sort of interaction with teacher belief. So people who think that way, that either you do get it or you don't get it, they'll tend to lend less support for the ones who don't get it. Because, it is more frustrating to teach somebody who's struggling with a subject. It's kind of more rewarding if somebody's really leaping on themselves. But they don't actually need the teaching so much. The ones who need the teaching are the ones who are doing worse. And so what the research seems to suggest is if you think they're not going to make it, you maybe give up on them a bit more and perhaps encourage more of this sort of bimodal distribution. But it's really not as wide a separation as people seem to think.
Interesting. Back in the 90s, there was a controversy when a Barbie doll came out where you pull the string on Barbie's back, and Barbie said, "Math is hard." And when someone gets that in their head early on, math is hard, then they've decided it is. Like, for example, I did poorly in calculus. And I'm starting to realize with, the hindsight behind me that they had built up calculus as being the most scary thing. It was the peak of my high school career. And, hope you survive calculus. I think that if I had been told from age 10 that it was going to be a great, fun, positive thing, it might have changed my attitude.
Yeah, and I think people can get early impressions of the subject that will make a big difference if they think, oh, this is hard, or this is, very intricate and technical, or this is difficult. And there's various sort of more social teaching tips that we perhaps didn't include here, but Greg Wilson, who's my co-author, is a sort of fan of them. People saying things like, oh, just do this. He recommends banning the word just, because it makes it sound like it's so simple. Why didn't you just do that? But the language can make a difference. So rather than try and sort of penalize people for not understanding the early concepts, just teach them the early concepts and support them in what they're doing. Don't make them feel sort of small if they don't immediately take to it.
Mm-hmm. I appreciate that you said that, because I've tweeted just before, and it seems like just and well actually seem to be like the words of the day right now. So often someone will say, why didn't you just, do a whatever kind of obscure bubble sort? And then it's like, wow, there's so much to unpack in that one sentence where you minimized me, told me I was a dumb, and then told me something I don't understand to use instead. Just it really is the evil in teaching.
Yeah, and I mean, I find myself saying just, but when you put this little thought into somebody's mind, don't say it. Then when you do find yourself saying it, you actually sort of reconsider, oh, am I doing that thing? It's hard to change your speech, and it's hard to sort of rule out doing things like that. But if you can just be a little bit more aware of it, it just helps. Aha, just.
Yeah, exactly. Does it matter though? Like, if I was talking with my wife about my son is struggling with some aspects of math right now, and we're struggling because he's lazy. He's just basically sloppy. He's being sloppy, and in order to save 5 minutes, so he can play, like he rushes through it, and then of course we have to go over his test, which takes double the time. So we're trying to explain to him, if you put 5 minutes more checking of your work, then you will save yourself like an hour of going over this later. And we were trying to figure out how to phrase it, and we are going back and forth about how gentle we should be, how encouraging we should be, versus how crisp we have to be. Like, you need to focus on this. You need, tough love, as they say. How important is the language that we use to encourage someone and make them successful?
Yeah, there have been some bits of research that suggest it can make a difference. And I think it often makes a difference if people are more nervous, to begin with, about perhaps if they're in a course, for example, about taking the course. And it may be that sort of minorities are a little bit more nervous about whether they fit in. So they're more easily put off by some of these sort of language issues. Whereas people who are maybe have some natural confidence and think they're going to get it, it maybe doesn't make that sort of much difference to them. So you just have to judge on a person by person basis, I think. Is this a person who I'm really going to knock if I give them some tough love? or is it someone who's overconfident and you just think, no, you've got to sort this out, and you can just say something quite frank to them and they'll take it on board.
Yeah, that's a good point. And because the last thing we want to do is push someone out of the industry or out of interest within a topic by being, by too much tough love. But at the same time, it does require work. It is a challenge.
Yeah, and that's come up recently, I think, with some of these discussions about Stack Overflow as to whether, what kind of attitudes that promotes to people, that people on there can sometimes be quite sort of dismissive or come across a bit more confrontational than they mean to. And for some people, that's fine. They love it. They thrive on it. And, they're happy with that. And for other people, it really puts them off. And the problem with the internet is when you write a public post, you've no idea who's on the other end reading it. So it's quite difficult to pitch your sort of tone right, I think.
Yeah, it absolutely is. And, one person might say, well, yeah, go and do the work, learn it, suck it up. And another person might say, yeah, and that was the Stack Overflow post that made me realize that people in computing are not nice, and I'm going to go do another whole industry.
Yeah, quite.
Yeah. You also propose that peer instruction, not just, teacher to student, but one-on-one tutoring, of course, certainly if the teacher can focus on the student entirely, that would be great. But an opportunity there is to take the other students and pair them up in appropriate levels of skill, and they can push each other forward.
Yeah, and part of this comes from a sort of modern interest in really scaling up education. Especially a few years ago, MOOCs were thought to be the answer. How do you scale up education? Well, you have one set of materials, and then you just have these sort of thousands and thousands of learners, reading materials and sort of operating on them independently. That seemed to produce sort of quite high dropout rates. So there's a question of whether that's maybe ideal. And we get this even in sort of traditional higher education. You might have a lecture theatre of 200, 300 students in some place. And how could you scale that? Obviously, you can have one lecturer standing at the front talking to them all, but they can't give individualized feedback to 300 students during the lecture. So peer instruction was an idea to try and make it a bit more interactive and a bit more scalable, that you join these people into maybe groups of 3 who are sitting next to each other. You perhaps ask them a question like, here's a piece of C code, what's it going to produce? And you have a particularly sort of tricky one with, an intricate corner case, so that people might get it wrong, they might get it right. You then get people to predict the answer. And following the prediction, you get them to discuss with their neighbours why they made the prediction. Obviously, it works best if they've made different predictions, and to discuss and talk among themselves about why they might be right or wrong. And in that way, you get individualised feedback on your misconceptions in a room potentially of any size, because you've got people talking to each other and trying to work through it together. So it's quite an interesting idea on how to sort of scale up learning, I think.
Mm-hmm. And just for people who may have missed it, at the beginning of that paragraph, you said MOOC,
right, yeah.
Massively open online courses, MOOC. Yeah. This idea that we can somehow let everyone learn if they just go online, join these massive online courses, which are fairly homogeneous in the way that they teach. I mean, you're in a browser already, you're online already. You're not really getting one-on-one experience, but it was an attempt to get to scale learning in the computer science realm.
Yes, yeah, and I think it's perhaps fair to say they were overhyped to begin with. I think they potentially have a role, but that there was a sort of thought that they would completely replace universities. And obviously I'm biased, I work at a university, but I think that's not going to happen. I think there'll be a space for sort of more informal learning along the lines of these MOOCs and for more formal learning still.
Mm-hmm. Well, one of the things that I found the most useful about formal learning, about sitting down and taking an electrical engineering class and building a clock from scratch using AND gates and OR gates and, that kind of stuff, was it helped me get a sense of the big picture. But I'm afraid I realized that as a programmer in my 40s, I have the benefit of history behind me. I've seen, Moore's law build layers on top of layers. I've gone from C to C++ to C#, and I've done Java. As I move my way up the stack, there's a new generation of developer out there who thinks that JavaScript is the metal, and they're coding on the metal at the lowest level of JavaScript, but they've got 3 virtual machines between them and the actual metal. Is that okay? Am I just a crusty old programmer and that I feel that people should learn the whole stack? Or is there some concept, a mental model that people should have to be an effective developer?
Yeah, I think it's still an open question. It comes to an issue in research that's called the notional machine, which is any programmer who's writing a program needs to be able to basically model in their head what's going to happen when the program runs, so that you have the code and then you've got this notional machine in your mind that you're essentially using to run the code. And obviously problems arise if your notional machine has a mismatch to the actual sort of machine. And perhaps early on that can come down to semantics, that you don't realize exactly what the instruction will do. I think it often crops up in professional programming in relation to things like performance, whether people have got an idea of what might be quick or what might be slow in their sort of notional machine, and whether that actually matches to what's quick or slow in the real machine.
Yeah, that brings up that idea of assumptions, right? And like at the beginning of our conversation, I made a couple of assumptions. You said, well, the research doesn't support that. I could make all kinds of assumptions about performance, about memory, about disk. I could build an entire system and then realize, oh, my disks are slower than I thought they were. And that assumption is now, the base of a house of cards for my entire solution.
Yeah, we see this in some of our learners sometimes. A very prevalent one is that people come in with notions about, for example, you write a for loop in C and you've got the I++ at the end. I hear sometimes from our students, oh no, plus I is quicker, or like I++ is quicker than I plus equals 1. These sort of very fine-grained differences. And these days with a modern compiler, there's not going to be a difference between any of those, three variants, but they have this notional machine that's actually a mismatch for the modern machine. And I think this is starting to come to the fore more and more now with C even, which people think of as bare metal. They're realizing actually the C notional machine doesn't correspond to what your processor is doing, very much at all. Things like the Spectre and Meltdown bug are related to how the processor actually works, but that's nowhere near most people's C notional machine, which they think of as bare metal.
That's really interesting. I mean, I think that the Spectre and Meltdown bug was a shakeup of the entire world's sense of their notional machine. We all thought it worked this way. But then I assume you had the same experience I did, where a couple of days after you kind of absorbed the bug and slept on the bug, you thought to yourself, oh, well, how could this have ever worked? Of course, this is, it's a huge problem. Like when we finally grokked what was going on, I could feel it in my chest. And I was like, oh, no, how did no one think about this? Because we just had a different idea in our head about what the machine was doing.
Yeah, I think so.
Hey, friends, this is Scott, and I've got a word from a new sponsor, and a really cool sponsor, in fact, that I use myself. They are Seek. That's SEQ, and you can check them out at getseek.net. That's GET. SEQ.net. Seek is the easiest way for your team to capture and search and visualize structured log events. You probably do logging. Maybe you have a Node app or an ASP.NET Core app. Move beyond text files. Check out structured logging. It preserves those individual property values as well as the text that's associated with each event. They get sent across the network to Seek, which then displays them and makes them searchable. It's really easy to get started. You can probably instrument your application if you're already using logging in just minutes. Just go to getseek, that's GET, SEQ.net. You install the Seek server. It's a Windows service. And then it listens and handles all of the logging, whether you're using Node.js and the Bunyan logging library, or maybe you use Serilog on .NET, or just ASP.NET Core's built-in logging. Seek is there for whatever you want to use, whether it be .NET or Node or Python or Java. It's a really great product, and I encourage you to check them out and support them the way that they support us here at Hansel Minutes.
And so relating to your sort of earlier question of do you need to know the full stack, I think if you've got a solid notional machine for JavaScript, then you don't need to know what's going on underneath. I have a reasonably sort of classic notional machine, C-esque of what's going on, but I don't really understand what's going on when you get down to the register renaming unit or whatever. And it's the job of the people on the layers beneath me to try and insulate me from that. One thing we find in programming education is a lot of the teachers often have this sort of full stack view of what's going on, that they're doing Java, but they know how the Java maps into, assembly code. And they feel like their students must also gain this knowledge. But there's sort of still an open question to some extent of whether the students don't need any of that knowledge. As long as they have a solid notional machine of their high-level language, it's fine. And I think we're sort of at a certain point in computing's chronology where a lot of the teachers are of the age that they have this kind of full-stack notional machine because they started with the more bare metal languages. And a lot of the learners coming in are just learning the high-level languages. And is it an issue? I suspect the cracks show through at points in the abstraction, but I think generally it's probably not an issue if people just have an accurate notional machine of the high-level languages.
I think that's a really good kind of gut check for me, because I'm so excited about the full stack that I'm excited to pour 25 years of software history into a 15-year-old mind. But ultimately, they just want to make some text flash on the screen. It's okay that their metal is different than my metal.
Yeah, and one of my sort of little hobby horse issues is whether we should teach binary or not. So it's generally thought to be a core part of computing, sort of binary and how the bits work and all that sort of thing. But actually, if you're building in your mind a JavaScript notional machine, you probably don't need any binary at all. You just need to know that it will store the numbers. You might need to know, for example, floating point representations and issues around sort of precision in numbers. But actually sort of getting down to kind of, choose complement things and what happens if you AND with a bit mask. Like a lot of high-level programming these days doesn't really need that. And people want to teach sort of, as you say, 15-year-old learners. And they're like, oh, we should really do binary because it's a fundamental concept of computing. And it is something that's quite distinct to computing. But if you're looking to become a programmer, I wouldn't say that actually binary was kind of, top of the list of things you need to know.
Yeah. When I first got a car, my father insisted that I would not be allowed to drive the car until I learned to change the oil. Of course, after the fact, I learned that you can pay someone to do that for you.
Yes.
And while, someone may judge me for my inability to change a tire, there's also people that will do that for you as well. None of which takes away from the joy of driving the car.
Yeah, and I think generally societal progress has to come from people specializing. No one can know all things. And so, I'm happy to pay someone to maintain the car. I have no idea about it, but I've specialized in computing. So, I'll earn my wage and pay him the money to do what he specialized in. And to some extent, computing is now large enough that nobody can understand all of what's going on in computing. You can't be an AI expert and a full stack expert and a processor design expert and a user interface expert. You've got to specialize in a particular subfield. And I think that's fine. And we shouldn't say that everyone needs to understand everything because it's sort of untenable.
And I think that the implied value judgments, that kind of the implicit value judgments rather, that go with that, we need to be careful that as teachers we don't make anyone feel bad about that. Like you don't know binary, or like you just said, for example, that you are not necessarily totally familiar with how the registers and stuff work. And my knee jerk was like, but he's got a PhD. You probably don't have a PhD in how registers and a CPU work, and that's okay.
Yeah, and I think that's another thing that can put people off is you get this sort of gatekeeping effect where people are like, oh, if you don't know X, you don't really know programming. If you don't understand what pointers are doing underneath, you don't really understand programming. But again, you could build a JavaScript notional machine without sort of, I think, fully understanding pointers or pointer arithmetic or any of that sort of thing.
I understand also that you believe that the way that I learned, which is with slides and PowerPoints, is really the worst possible way to learn how to code. That better to have the instructor write the code on the screen, almost like mob programming.
Yeah, so this is particularly for how to sort of teach and learn programming. But there was a study that looked at sort of learners' experience in lecturers. And they, a real novice would come to a computing lecture, they'd sit down, the lecturer would show a slide with code on it, they'd show another slide with code on it. And from the sort of viewer's perspective, all this code is perfect. they sort of get the impression that the person must have written this code perfect first time, that they can just summon it up out of their mind just as easily as they click on the next slide button. And they don't get any sense of process or the struggles that go with that process or anything like that. Whereas if you do live coding on the screen, then often you'll kind of make, where you make typing mistakes, as in, physical typing, not types. Does that make sense?
Yeah.
Keyboard mistakes. So you'll make keyboard mistakes. You'll maybe, if you sort of do longer examples, you'll screw something up in the middle and you'll be like, oh, what happened there? What's that error? And actually seeing somebody go through the process of making errors and tracking down errors is very useful for them to learn. It's okay to make errors. Here's what you do about it, and so on. And there's this sort of weird effect where actually the more practiced and smooth you are as a programmer, probably the worse you are at trying to do sort of live coding to teach, because you don't make mistakes. I have this workshop that I do for some of our software, and I've done it so many times I can do it, without making any mistakes. And that's actually not very useful, because seeing the mistakes is an important part of sort of the teaching process.
Yeah, I like to say that senior developers really have just failed a lot more than you have, and the really senior developers fail very, very fast. Fail fast, fail often, and if you can shorten the what I call and what we at Microsoft call the developer's inner loop. The shorter that loop can be, the better. Like if your loop when you're a beginner might be an hour before you realize you've made a mistake, but if you can do that in minutes or seconds, failing as quickly as possible is going to make you very successful.
Yeah, and that's something we've actually looked at in the design of some of our beginners IDEs, because we've seen behaviors where learners will write a long bit of code, maybe 20 lines, which as a beginner is a really big program. They'll write 20 lines of code, which is, often got syntax mistakes and, conceptual mistakes and whatever in it. And then they hit the compile button, or if you know dynamic language, a run button. And they just get hit with a wall of mistakes. And so one thing we looked at doing was, can we switch to sort of more professional IDE style error highlighting as you go? Is that a better sort of feedback loop? Instinctively, you'd think it probably is, because a shorter feedback loop, as you say, generally that seems to work out better for people when learning things.
Mm-hmm. And you also say that people spend too much time typing in boilerplate code. If I'm trying to say hello world, why am I typing library import statements and curly braces and namespaces and stuff? Live coding doesn't have to start with a blank screen.
Yeah, exactly. There's sort of one of the conceptions is that you must understand everything that you type and everything that you interact with. And people have always criticized Java for its public static void main that doesn't really make any sense to beginners. But in a lot of languages and a lot of frameworks, you often have to have some code that a beginner won't understand. And you can either, sort of struggle against the tide and try and explain every single piece in that file before you get going, or you just accept, okay, they're not going to understand all of it. Some of it's going to be boilerplate. Give them the boilerplate so that they don't sort of have to look at it, and then just focus in on what you actually want them to write. And it's better if you can hide it behind a software library or a framework so that they don't see this extra code. But sometimes you do actually have to just put it in the file that they're editing. But it's all about, computer science is about abstraction. You try and abstract away all the bits they don't need to know, so that you can focus on the bits they do need to know. It's what we do with libraries, and it's no surprise if we also do it with teaching.
Mm-hmm. Yeah, the public static void main is awful. If you think about, let's learn how to program. We're going to say hello world, public static void main. Well, now here's 4 concepts that you need to learn deeply about before we can say hello world. Yeah,
and so the better thing to do is just say, okay, ignore that bit. That's just got to be there. Mm-hmm. Let's type the code in between the curly brackets here. And then you're typing one line to say hello world. It's simpler.
One of your tips is that when teaching, we should use authentic tasks, and I took that to mean like real and to matter to the student, to the kid. If they're a teenager, they might be more excited about listing out MP3s or looking at SoundCloud or talking to someone like that, and not interested in making Bezier curves and drawing spirographs.
Yeah. It's often a balance between what you can do in a small amount of code with a small amount of concepts versus sort of trying to make it really engaging and interesting. But historically, programming used a lot of examples, certainly when, I remember in the 80s or so, it was kind of, printing numbers or printing prime numbers or a lot of, because all you had was like the console to print out to. And so those examples are quite sort of dry. They don't encourage a lot of experimentation. If you're not very mathematically minded, all the numerical ones will generally be a turn off. So more interesting, more engaging examples are better. There's sort of one idea in computing education of media computation, which is trying to compute with sound and images so that you get a good sort of quick idea of whether your code worked. If you try and turn your image upside down, you'll see whether you managed it successfully or not. And it maybe makes a sort of more interesting task than these very dry tasks.
Mm-hmm. Yeah, I think that it's important to point out that not every bit of context is appropriate for everyone. There's cultural reasons to pick one over another. There's generational things. If I were teaching a room full of seniors, I might pick a different context than if I were teaching a room full of 6-year-olds.
Yeah, and you'll never satisfy everybody with one example. So, obviously a variety is good if you've got them for the long term. And just trying to sort of, use the domain to make it relatable and engage as many people as you can.
Mm-hmm. And the kind of the final tip, at least we haven't gone through all 10, and I'll have links to this, of course, in the show notes, is you shouldn't just code. You want to break things down. There's syntax, there's semantics, there's algorithms. Coding isn't just kind of rote memorization and slap on the keyboard.
Yeah, and there's this idea of Parsons problems, which is where you give people preformed lines of code, but you get them to organize it into the right order and the right scopes. So it's sort of like a kind of rearrangement puzzle rather than a programming puzzle. The issue, if you just get them to code from nothing, is, it requires a lot of sort of memorizing the commands, and it can be quite intimidating. There are other ways to learn programming concepts and learn code other than just bashing it all out yourself, whether that's sort of code reading tasks, code manipulation tasks. There's a wider variety if you could just be a little bit more imaginative about what you're doing.
Mm-hmm. You said Parsons, P-A-R-S-O-N problem. So this is where I would give you, say, 3 or 4 lines of code in the wrong order, and I would put them together in the right order?
Yep. Yeah, that's right.
Interesting. And that's kind of like a multiple choice, but it's much more complicated because it has, because order matters.
Yes, yeah. So people learn things like the variable declaration has to go before the variable use if you're doing a language where you require declarations, or these lines must go in the if rather than outside the if. It's useful if you're really at the beginning.
Mm-hmm. So, other than your paper, which I've included a link to, what are some other resources that we can leave people with if they are out there either teaching programming, or maybe they're just going to user groups and trying to teach some subject to their peers?
Yeah, so my co-author on the paper, Greg Wilson, has done a lot with software carpentry, which are these schemes to try and teach people how to program. And I think they're particularly interested in sort of, not data scientists, but sort of just scientists, people who maybe need to do some programming as part of their analysis, maybe to do some data tidy up, or to use a particular R library on what they're doing, and don't really know much programming. So they're like, these sort of adult learners, but you need to just get to grips with bits of it to learn how to program. So software carpentry's got a lot of interesting resources on, especially sort of teaching adults or people who don't want to become full-time programmers, but they need a bit of programming to get on with what they're doing.
I like that, actually. Such software-carpentry.org, and I like the implied analogy there, because my dad is a formal woodworker and a craftsperson, but sometimes I just want to cut a piece of wood. Finding the right balance between how deep do I want to go. You don't necessarily have to learn computer science to put up a WordPress site. Yeah,
exactly. And a lot of people, they need these sort of small bits of programs to maybe read in a CSV and, manipulate a string and write it out again. They don't need to be sat down and told, okay, here's sort of the history of object orientation and how the, register renaming unit works and all the rest of it. They just need a little bit to get on with what they're doing. And it's okay if they don't understand the full thing, if they're just writing a bit of code to do a job.
Very cool. Well, thanks so much for taking the time to chat with us today.
That's okay. It's been great.
This has been another episode of Hansel Minutes, and we'll see you again next week.